So now let's make the PLC actually control something. You've seen that the software for programming the PLC is the Click Koyo software. You can download that software and run it on your home computer. All the lab machines have it installed. You can run it there. But the PLC that we will use for actually controlling things, at least for the learning the programming part of the course, is a PLC that is not the one you use. It's connected to the instructor station, and you have to connect to it. In fact, I'm currently connected to it. Let me disconnect and show you where it's at. So if I hit connect to talk to that PLC, I showed you how you'll usually program with USB, but I'm programming with Ethernet because this PLC is a little bit special. Instead of connecting to the computer via USB, it connects via Ethernet. And so it's not actually connected just to that computer. You could connect to that computer from any lab machine in the room. You could connect to that PLC from any lab machine in the room. All you need is the IP address, the subnet mask, and you should be able to read them off here and connect to it. So you may have to change these settings in the Click software. Just choose Ethernet and make sure you've got the IP address and subnet mask. But I think if you click Ethernet, it'll go find it, and it finds it pretty quickly. So it's right now in run mode. Status is good. There's the MAC address. You may have to put that in. I don't remember right now. I don't think so. I don't think you need the MAC address. But anyway, so I'm going to hit connect, and I can either read the project from the PLC or not. I have a blank. Well, I put a project in the PLC. I don't want to read it, so I'm going to do that. And then I'm going to make a project. Before I do, what will the PLC control? Because the physical PLC's not actually connected to any switches and lights and all those sorts of things. Well, for a lot of this class, in order to learn to program and to focus on the details of programming and not so much the details of wiring, we're going to simulate some systems. So we're going to use another software package, and this software package is only installed on the instructor station. So when you want to test out your code and try to run and control something that's not real, that's a simulated system, you will have to do it with this PLC and with the instructor station. So you will need to log in to the instructor station in that room. And that computer number is the 00 computer number. It's when you go to the SLIC site, I think it is, that I showed you, and you're connecting to a remote lab machine, it's the first lab machine in room 1136. So the software we're going to use for simulation is called Factory I/O, and all it really does is just simulate all the different items that we would want to control, all the inputs and outputs and things. Now we're going to need to see both of these. This is my programming software, so I'm going to move it off to one side. And this is the simulation software, so I'm going to move it to the other side, to the left. I have already made what's called a scene, but there are several scenes that come with Factory I/O. So there's all these different systems that Factory I/O can simulate, and you have the challenge of programming the PLC to control these systems. So it's as if we have these systems sitting right there in the lab, and you can make your PLC control them. Of course, they don't actually take up space because they're simulated here on this one computer. But I did make a custom scene, and I would not expect you guys to make any of these scenes, but I made this custom scene, and I don't know if you guys watch the channel Let's Game It Out. If you do, probably you shouldn't with children around. There's a few swear words and things, but he usually plays video games, and he makes fun of video games and does things backwards, and it's pretty hilarious if you get the chance to check him out. But this reminds me of something he would do, because there's this start button just hanging out in the middle of nowhere. Now this is not a video game, obviously we're learning something here, but it almost looks like one. So this is what's called a stack light over here, and this is a push button. And so we have one push button, which is an input. We've got three outputs, obviously, three separate lights. There's also a lamp in this button. This is an illuminated push button, and you can turn it on or off. In fact, one thing you do need to know how to do is see all of the inputs and outputs associated with a scene, with a particular simulation. So if you say view, dock all tags, then it will show you all of the input devices and all the output devices that particular simulation has. So not surprisingly, this has a red output, that's the red lamp. It has stack light 1 green down here, stack light 1 yellow, that's obviously here. then start button 1, you notice the symbol for it's a little different. That's because it's an input to the PLC, or it's an output from the simulator that goes to an input on the PLC. And then there's a lamp associated with the start button. Now I have to write in my PLC program on one side how to control factory I/O on the other. So to do that, I've got to make the two talk to each other. Now, in the real world, what we would do if we really had this push button, we really had these stack lights, we would wire them to the real PLC. Now, of course, they would need power and all that sort of thing, but we're pushing that information off. We'll do that. We're just pushing that off and setting it aside for a minute so that you can learn some details about programming first, and then you'll have a little bit of information. We'll jump over to wiring. We'll work a project there, and then I'll teach you more advanced programming skills a little bit later in the course. But for now, we're going to simulate this system just so you can learn a little bit of programming. Now, this little palette here will probably be in your way. You can turn it off right here. Just turn off the palette window. You don't need it. It's so that you can add items to the simulation, but you won't need to do that. The one thing you will need to do, though, is connect factory I/O to the PLC that's supposed to be controlling that. To do it, you click you click driver, file, and then drivers. And I've already got it configured, but let me show you what you may or may not need to do. Now, in the simulations that I give you and I have you work with, they should already be configured where you really don't have to do anything except hit connect. But I'll show you the gory details so you can see where all this comes from. You don't want server, you want client. We're talking Modbus. Modbus is a standard communication protocol, and it allows the PLC to talk to factory I/O. So Modbus over TCP/IP, in other words over Ethernet. We want client, so this is set up as a client. Factory I/O is set up as a client. And it's a little confusing because you see coils here, and so this is not referring, this seems confusing because this is the IP address, for example, of the PLC. And so it looks like they've got outputs here because you would consider those coils and inputs over here. So you feel like you need to connect factory I/O input devices like this button to the input side. But that's not the way it works. Basically what they're saying is that this button is going to trigger an internal coil in the PLC, turning that input on, which actually makes sense. Why they call this input, I could go into that. It doesn't matter too much. You can configure that. But in configuration, I had to set the IP address, and that's always going to be the same. That won't change. The port number by default is 502, so I just left it there. And then what you really need, if you wanted to change the names of things, you could do this. You could do it here. Read digital inputs or coils and read registers. I'm just going to leave them as they are. If you look down here, you'll see where we've got an offset for digital inputs. So what inputs do we want to use? Well, we might want to use just regular inputs. Like, for example, if I drag an instruction over here and I'm programming the PLC now and I want to use, say, X001 as an input. Well, X001, let me show you some detail about this. We can either go to address picker here or we can click through here. I'll go through address picker. Whoop, let me try that again. I'll go through address picker, and what you'll notice, normally it comes up and it looks like this. What you'll notice, X001, I need the Modbus address of that, so I have to actually expand this window, tell it to display Modbus addresses, and we're talking 984, not hex addresses. And what you notice is that the number for the inputs start at, what is that, 100,001? So you might think, okay, no problem, the inputs are at 100,001. And you notice it didn't put that 1 in. It only goes up to a maximum of 10,000. So I'm in discussion with factory I/O whether or not this can be changed so that we can actually use input addresses. But I'm not sure that it will work anyway, because input addresses are memory lots or memory spots that are driven by what's physically connected to that input point on the PLC. I don't have any physical connections right now. So what I'm going to do instead is connect the button up instead of, literally to the computer or to the PLC, which I can't do because the button's not a physical button. I'm going to connect it up to a memory address instead. So we're going to hook it up to a control relay. And you'll notice that the Modbus address for the control relay starts at 16,385. Now here's something kind of strange. There's an offset of 1 between these two. So if you read 16,385 as the address here, the address you need to give factory I/O is 1 less than that. So it's 16,384. It has to do, I think, with the fact that Automation Direct starts counting at 1 for their inputs and addresses and things rather than 0. It doesn't matter. The point is, in the first place, you shouldn't have to do this. I should already have it set up for you. It's just I'm showing you this detail in case something goes wrong and you're trying to troubleshoot. And then this is how many different input addresses you want as inputs, to the PLC. So it doesn't really matter. I only really need 1 for the one button, but I'm going to go ahead and make that 4. And then the digital outputs. Well, factory I/O has to know where are the outputs that the PLC has. So where does it go to get its data to see what it's supposed to do? So the lights, for example, I need to connect the lights somehow. Well, for that you can actually use the actual output addresses. If you go online and you see people doing this, you can do a search on YouTube for Click, Koyo, and Factory I/O, and you'll find other people doing this. All of them that I've found use control relay addresses for their outputs as well. I prefer not to do that for introductory purposes. I would rather use the actual output addresses. Now for mapped I/O, which is a good idea, you would use all control relay addresses. But for the sake of understanding the difference between inputs and outputs, I'm going to use actual output addresses. What you'll notice is that the first output address, Y001, is at 8193. Well, it's not exactly. You got to subtract 1 from that. It's from 81, or it's at 8192. So I have typed 8192 in here. Now the number of outputs I really need are 4, so I'm just going to put 4 there. And you don't have to save or anything. You just go back, and that's it. It's done. It's connected. Now you'll notice I have already connected the start button here. The way I did that was I dragged it over, and it's like wiring. Basically, I've taken that push button switch and I have wired it into the PLC, going to Modbus address 16384. Well, not exactly, right? I mean, in the PLC, Automation Direct calls that 16385. Remember the 1 address or the 1 unit offset there. So the start button's wired in here, and then the stack lights and start button lights I have wired in to address 8192 through 8195. Remember, I'm using actual outputs for this, and they start at 8193, but I got to go to 8192. Why that is, it doesn't matter. I don't know. It doesn't matter. But then I hit connect, and so now, if it takes a long time, you know that something's gone wrong, but when it connects immediately as you see that green check mark, that means that the PLC and the factory I/O software is talking. Now that does not mean that this software, the programming software, is talking to factory I/O. That is not what it means at all. The programming software is just to write your program into the PLC. It's the physical PLC now that is talking to factory I/O, even though it's in a lab, far away from me and I'm at home. I'm connected to that computer remotely and running it from here. So what I want to have happen, I can't use X001, that won't work. I will have to use some of the control register relays. Remember, I was going to use those as inputs. So I will choose C1 and let's just name it start button. It's not going to actually start anything. I just want to show you a system that actually does something. So let's see, we'll choose C1, pickup mode, and notice how it moves the screen over here. When you need to see the Modbus addresses, you got to drag that window open and tell it to show you them to you. Anyway, so I'll hit OK, and now that will be our input. Okay, so that's the condition. So now that should be wired up virtually to the button, and then I'd like to see a light come on. So let's go to Y001, and of course I'd like to name that. So Y001, that was the first output over here. That was 8192, even though the Modbus address says that it's 8193. See? Remember that 1 offset. So this is stack light 1 red. So let's just name it. Whoops. Edit mode. And we will name it stack light 1 red. Pickup mode, select that one, OK, and there we go. Now, a mistake that most students make is they try to download and run this immediately. There's a problem here. There's one bug. Let me show it to you. If I tell it to download or write that project into the PLC, it'll say, oh, you got a syntax error. There's a problem. Notice what it says down here. It says there's no unconditional end. Why it wants that, I don't know. This is an Automation Direct thing, but it's okay. We'll put it there. And then the PLC will be just fine and dandy. So now we tell it to download. It says, okay, what do you want to call it? Well, I'll call it, I'm going to put it on the desktop because I'm going to delete it when I'm done. That was my folder for development work. Let's just say button demonstration. And what I'll do is I'll go ahead and post this code as well when I'm done with it. So save that. I'll put it on Brightspace. Now what it's saying here is that the setup for the Ethernet port in the program is different than the PLC it's talking to. So it's talking to this PLC over here that's been set up manually, but the default IP address, subnet mask, and all that stuff is just what the program has when you hit new program. So I'm going to tell it to, I don't want to hit this button. That would copy the default setup here over here. I don't want to do that. I want to use the setup from the PLC that's actually talking to the Automation Direct programming software. And now you notice that the project size is tiny. You can barely see it. Most of the memory in the PLC is available. So I'll just hit OK. It'll say, well, the PLC's in run mode. Do you want to change it to stop? I always do this. By default, the new version of Automation Direct's programming software has this runtime edit checked. I don't like that because I believe what that means is that while the PLC is actually running the ladder, you download the next one and just start with that new program. I don't like that, so I unchecked it and it comes up with this. If you don't uncheck it, it won't come up with this. So it will in software change the PLC from run mode to stop mode, and you notice up here that it's in stop mode. It says the transfer is complete, so this program's now in the memory, and it says okay, it's stopped, do you want to move it into run mode? So I'll say yes. So now it's actually running, and a nice thing too is that we are monitoring the PLC. Well, we were, that's by default. Monitor and then status monitor allows you to use the programming software to see what's going on in the PLC. So now we're looking at the PLC and we notice that nothing's happening, right? There's no input that's true, so it hasn't set this output as true. So let's go press the button and see what happens. So now we're in factory I/O with our floating buttons, and I got to zoom in just a little bit. There we go. Floating buttons, and when I press this button, what should happen is we should see this input come on here, and that should go to the Modbus address associated with this C1 in the PLC and turn it on, which should turn on this. Now this is not really happening in the software. This software is just looking at what's going on in the PLC. So what will happen actually is when I push this button, the memory address in the PLC will turn on. The PLC is running this program, so it will turn on, hopefully stack light red. Let's find out. So I'll hold down the button. Remember, it's a momentary button, so I've got to hold it down. Oh, well, it would help to put it in run mode. Let's have factory I/O run. There we go. So now we're actually running. We're not editing the scene. And sure enough, when I held down the button, you notice that the red lamp comes on, and you notice that the monitoring shows that inside of the PLC, what the PLC saw was a memory address come on. C1 came on. And then the PLC said, okay, well, according to my ladder logic, now, by the way, I'm holding down this button so that the button stays active. In the ladder logic, when that memory address is on, that means I need to turn on output Y001. And so it did that. Now Y001, if we were looking at the real PLC, if we were sitting in the lab looking at it, there's a little lamp beside that particular output, and that lamp is literally on right now. Now that lamp is not the simulated lamp over here. That lamp is just a diagnostic lamp on that output point on the PLC. But what's neat is that you see that this address, Y001, is tied back through Modbus to that particular lamp, that red lamp, and the red lamp's on. If I release the button, like that, well then that address goes off, the PLC turns off that output, and sure enough, the red lamp goes off. Now let's do something interesting here. Let's change our program so we turn on all the lamps. We got 1, 2, 3, 4 lamps. Let's just make them all come on. So let's go over here and we will drag in a new output, and that address would be Y002. It's the next one in line. And the way I know it's the next one in line, by the way, is if I go over here into Factory I/O and I go to the drivers and look at my setup, I have connected the actuators that are available this way. I haven't connected all of them, right? There's actually other outputs that Factory I/O gives you available. For example, the PLC could turn Factory I/O into run mode or pause or reset or whatever. And so there's other information too that Factory I/O gives back. But the only ones I really care about right now are the start button and the lamps that are being simulated as if they were a real system. But I've connected the red lamp on this particular output. I've connected the green lamp down here. The yellow lamp I've put up here. Why they're not in order over here, I don't know. They're actually red, yellow, green, just like a stop lamp. So I put them as red, yellow, green, just like a stoplight. And then I've got the start button light attached here. So my addresses are Y001, 2, 3, and 4 respectively. So what I'm going to do is just go ahead in the Click programming software and change the various names. So I want to name these what they really are. So this is Stack Light 2 and it is yellow. And Y003 is Stack Light 3 and it is green. Finally, this is the start button lamp. There we go. And so what I want for this address is Y002. I'll go back into pickup mode, make sure I get it, there we go, and hit OK. Now I don't have any conditions for this, so what I'm going to do is use the exact same conditions. Hit OK, there we go. I'm going to use the exact same conditions for driving that lamp. It's just whenever the button is pressed, I want that lamp to come on. So drag a couple more outputs here. Y003 is the next one. Remember, I've already named these. And then finally Y004. Same condition for all of them. C1. C1, there we go. And don't forget that I need an end command. There we are. Now I want to write that into the PLC. So I download it to the PLC or write the project. Hit OK. Yes, change to stop mode. It's in stop mode. Transfer is complete. Change back to run mode. And let's see if that does what I wanted. So let's see. It should be running. I should be able to press the button. Let's find out. I'm going to press the mouse button to push the button on the screen, and it worked. So you notice that the monitor of the PLC is, and of course I'm holding the button in by holding the mouse button down while I describe it, but you notice that the conditions are all if the start button is pressed, which it is, then turn on all these various lamps, and so it does. So all three of the lamps are on. Now maybe that's what we want. Maybe we want different behavior. For example, maybe over here instead, if I use an inversion instruction, maybe I want a couple of lamps to be on when the button is not pressed. So this is an inverting instruction. What it'll do is when the button, which is normally open, is false, then this will invert that and give me a true. So the yellow lamp will be on. Just to show you that this works, let's do the same thing for the other button as well. There we go. Now, this won't work yet because this is not what's running on the PLC. What's running on the PLC is what I had a minute ago. This is just where I'm programming it, and now I've got to download this program to the physical PLC that's in the lab. So now it says it'll download, so I say OK. Put it into stop mode. That way the PLC is not actually running right now. I'll put it back into run mode, and now it's running. So you notice over here in Factory I/O that the green and yellow lamps are on. Let me prove it to you. I will press the button. What will happen is the yellow and green lamps will turn off and the red lamp will turn on. So let's press it. Here we go. And sure enough, that's exactly what happens. So when I press the button, the red lamp is on. You can see that in the code as well. The code here is not the actual code that's running. It's a copy of it, right? It's looking at what's going on inside of the PLC's brain, if you will. And when I release the button, the inverse of off, the button being off, is on, and so the yellow and the green lamps come on. If that's not what I wanted, maybe I wanted just to have the yellow lamp on when the button's pressed. So I'll have to download this and see what happens. So hit OK, transfer it. Transfer is complete. Change it to run mode. And when I hold down the button, you notice that the red and yellow lamps are on. When I release it, the green lamp's on. So it's a fairly simple program. It does something simple. It's kind of strange that the button's just, hanging out here in midair, but at least we didn't have to wire anything to the PLC, and you get to see the PLC instructions work. Now, an interesting thing is when you start to get into more complicated programming and there's more conditions for the outputs to either be on or off. So this can get a whole lot more complicated, but I want you to understand the basics and be able to do something with the PLC. I know it's a little bit confusing at first to have one program over here talking to the PLC and another one over here, but think of this factory I/O program as just a system that's sitting in the lab, and that you don't have to worry too much about the details of wiring it, because most of the time I've already wired it virtually for you through this this driver thing, through this configuration, and I've already selected all the addresses. The only thing you'll have to figure out, and I'll try to put some notes with it too, but the only thing you'll have to know is what addresses go where, because you will have to probably look at this and see how I've wired things up and understand how the address numbers relate back to, say, C1 or Y1 or any of those things.